This is some really cool work that I've done with my collaborators at Apple. And this is our system called mage. So let's talk about fluid moves between code and graphical work in computational notebooks. So this is a notebook today. I'm going to load in some data. I'm going to load in my favorite data set, which is a data set of Pokemon. And we're going to look at what this data looks like in a typical notebook and the level of interactivity that notebooks support today. So I see this nice table, and this is really useful for seeing the table in the notebook so I can visualize my data. But you'll notice that the table itself is not interactive. I can't do anything with it. Now, in recent years, we've seen some really compelling examples of how we can push notebooks to be more interactive and more deeply combine complex GUI work. So see, we have, for example, B2, where we're able to do complex visualization work with interactive visualization dashboards directly in the notebook alongside our code. Here we have some interactive tables that behave more like spreadsheets we'd see in Numbers or Excel. And all of these examples are really compelling. These today require a significant extension of the notebook. And what we'd like to see is a more general way that we can approach these style of interactions where we can fluidly work with our data in both complex GUI tools and in notebooks. And the goal of this work is to push the way that we compute with data in general, not just in notebooks, but here we'll focus on notebooks. So our work is the Mage API, in which we've extended how notebooks work in general to support this class of interaction, where we can support a wide variety of complex interactive GUI tools that produce real work in the notebook. So they auto-generate code as well as changes in a GUI interface. Let's see what this means. So once again, I'm going to pull up a table of my Pokemon. This time I'm going to use the Mage API to summon a table. Now this table looks a lot like the table we saw the first time, but there's one key difference. So as I scroll along looking at my columns, I can actually start to do real work in this table. So I'm going to move the name of the Pokemon to the front of this table. And when I do that, it generates code to ensure that my work is reproducible and my work can be permanent in the state of the notebook in both code and in this GUI representation. So that's what Mage is doing. It's allowing fluid work back and forth between code and GUI. Let's show another example. So this time I want to summon a plot for my Pokemon dataset. I want to be able to look at different visualizations. Now this is a visualization GUI we've created based on Voyager and Vega Lite. As I use the different operations, I can make these nice visualizations of, for instance, all of my types of Pokemon, and it's automatically generating a Vega Lite specification. Now as I select some data in my chart, I can actually use it to produce more code just through drag and drop or open another tool. So here I'm gonna sort my psychic Pokemon, and I can directly edit the code to change what I'm seeing in the table and my data set, or change it in the data set within the GUI tool. Either way just works. So this is what we'd like to see. Code and GUI alongside each other, both ways simply work without any fuss or extra complication. So what we did to produce our API is we created the two tools you just saw, the plot tool, the table tool, as well as all these other tools, a lot more detail in the paper. We created these tools to test the boundaries of what our API needs to support, and we also demonstrated these tools directly to professional data scientists to get their feedback on this kind of interaction. Now, how Mage works, very simplified, is that it handles the aspects of the user's programming environment to provide a tool creator with what information they need to display appropriate context information in the user's environment. Now, as the user works, they can summon using the summon command, the GUI tool along with the data that the tool requires. And as they take action within a GUI tool, Mage is going to auto-generate code that corresponds to the work they've done. And this code is provided by code templates the tool creator uses that Mage fills in using aspects of the user's programming environment. Now, there's a lot more details in the paper of how this all breaks down and works, so I'm really hoping if you find this vision compelling that you'll check out our paper, and hopefully we'll see notebook and computations work more like this in the future. Thank you.